I want to go ahead and do a couple of examples of some homework problems you're now going to have in section 2.2 of the book. Although you will see that the problems I'm going to do, you're going to be continually doing these for the next few sections. And I'm specifically thinking about this, the problems 29 through 34. The instructions say, find the equation of the line that is tangent to the graph of the given function at the specified point. In a minute, I'm going to do number 32, although I'm going to do one other problem before that. So for example, you see that, hope this is not too blurry. You can see that you're given, in this case, it's actually an equation. Same thing as a function. And here's the point. So I'll do a couple of examples of this. But just once again, just to take a quick minute and explain the principle. The idea now is say we have some kind of a function. Let's look at it in terms of a graph just to get the principle of it. And let's say that they are say this point, maybe this point is this point is like 6, 3, x is 6, y is 3. So here's a point on the function. And what they're saying is they want the equation of the tangent line at this point. So the idea is, right, if I were to draw the tangent line, right, it's the line that touches the graph at this one point and sort of comes up right next to the graph. So basically, here's the equation of a straight line, the slope-intercept form. So they want the equation of this line. Well, the way we're going to do it, we're actually going to use, there's an equation, a little formula that we have. If you know a point on your line, which we do, this is going to be a point. And if you know the slope of this line, and we're going to determine the slope of the tangent line by finding the slope of the curve at this point. Because once again, the slope of the curve at this point is the same as the slope of the tangent line. So that's the equation is y minus y1 equals mx minus x1, where m is the slope of the line and x1, y1 is a point on the line. Now, the way calculus comes in, obviously, we already know for this problem right here, the one I just made up, we know the point on the line. Now we have to find the slope of this line. Well, the way we're going to find the slope of this tangent line is we're going to find the slope at this point of the curve of this function. And the way we do that is we're going to take the first derivative of this function because the first derivative is the slope. So we're going to find the first derivative of this function, and then we're going to plug in x equals 6 into the first derivative, and that gives us the slope of the curve at this point, which is the same thing as the slope of the tangent line. So we're really trying to find this tangent line. We need two things, the slope and the point. They give us the point. We need to find the slope. The way we're going to find the slope, it's almost like you have to jump through a hoop. To find the slope of the tangent line, we're going to find the slope of the point on the curve. And the way you do that is by using the first derivative. Hopefully that was clear. If not, after I do these couple examples, you'll understand it, because this is a pretty key concept. These are the kinds of problems they like to assign to you. So the first one I just sort of made up. It's pretty straightforward. So here is an equation for a function y equals x squared plus 4x plus 3. And I want to find the equation of the tangent line. And the point is going to be -1, 0. So I'm going to solve this problem. Although as soon as I finish, I've actually created the graph of this function, then you can visually see how it all ties together. So once again, here's the equation I'm going to use, the point slope equation. Oops. So my point, here's x1, here's y1. Now I need to just find the slope of the tangent line, and I can plug things in and I'll have the equation of the tangent line. But the way I'm going to get the slope is I'm going to take this function, this equation, and I'm going to take the derivative. Because once again, when I do that, the derivative is the same thing as the slope. So now, using the power rule, we know how to take the derivative of this equation. So here's my derivative. So what happens is, here's an equation that will give me the derivative for any value of x. I can choose whatever value of x I want. If I plug it in here, that will give me the derivative or the slope at that point. Well, you know what? For the slope of my tangent line, it's going to be the slope of the curve when x is -1. So I'll write it like this. I'm going to find the derivative or the slope when x is -1, which means I'm going to take this derivative. I'm going to plug in -1 for x. So -2 plus 4 is 2. So this is the slope at x equals -1. It's the slope of that point on the curve, but it's also going to be the slope of the tangent line at that point. So now I have the slope of my tangent line. It's going to be 2. I have my point. So now I can actually go in and find the equation of the tangent line. So y minus y of my point, which is 0, equals the slope of my tangent line, which I just found it to be 2, and then x minus x of my point, which is -1. So now I just want to get y by itself, and once y is by itself, this should be the equation of my tangent line. So this is going to be x plus 1. If I distribute to parentheses. So this is the equation of the tangent line at x equals -1. Now, just to sort of help you visualize it, I took this equation and I made a graph. So let's visualize what we're doing. So they're saying on this graph, on this function, go to the point -1, 0. Well, you can see here's my origin. So -1, 0 is right here. So this right here is -1, 0. Now, I'm not going to draw it yet. I'll draw it in a minute, but you can imagine here the tangent line will look something like this. And what we just found a few minutes ago was the equation for this tangent line. So what I'm actually going to do, I'm just going to go on to this graph and I'm going to plot this tangent line, and it should look just like this. So if I plot this line, just like a standard line, y-intercept of 2, and I know it goes through this point. So if I grab my ruler just to make I have a nice straight line. So this is the tangent line. This is what we just found. And if you look, it says the slope should be 2. If I go from here to here, I go up here, that's 2. I go here, I've gone 1. Yep, the slope is 2. The y-intercept is 2. So the idea of this problem is you're given this function, this equation, and then you're given a point on the curve, and you're asked to find the equation of this line. So what we do is we're going to use this point, and then we also need to have the slope of the tangent line, but that's the same thing as the slope of the curve. And I can find the slope of the curve by using the first derivative. So the first derivative is the way that I'm going to find the slope of my tangent line. I need to know the slope of my tangent line to figure out the equation of the line. And the way I'm going to find that slope is by using the first derivative. All right, let me do one more example. Hopefully it's becoming clear what these problems are all about. Let me do one out of the book. I'll do one of the even numbered ones. I'm going to do number 32. Looks a little messier, a little more complicated. So let me write it down. Y equals the square root of x cubed minus x squared plus 16 over x squared. And the point that we're going to look at on the curve and the point at which we're going to create our tangent line is 4, -7. So this is the point. So once again, what we're going to do now is, if I want to look at if I want the equation of the tangent line, once again, just to make it very obvious, here's my point slope equation. I know x1 and y1. I now need to find the slope of the tangent line. The way I'm going to find the slope of the tangent line is to take the first derivative of this function. Then I'm going to plug in my value of x4, and that'll give me the slope of this point on the curve, which is the same thing as the slope of the tangent line. So if I'm going to take the derivative of this is going to be using the power rule. First thing I have to do is sort of rewrite some of this so I can apply the power rule. In other words, I need to change this to a rational exponent. The second term is fine. The third term, I need to move the variable up to the top, so it becomes x to the -2. So now I can take the derivative by using the power rule on all 3 of these terms. So this first one, the 3/2 comes down front, and I subtract 1 from the exponent. Second one's pretty straightforward. It's going to be 2x. This last one, you have the 16, the -2 comes down front. And when I subtract 1, this becomes x to the -3. Now let me maybe clean this up a little bit. Let's do this. I'll call this 3/2 square root of x minus 2x minus 32 over x cubed. So now this is my first derivative. This I can also think of, this is an equation for the slope at any point on my curve or on my function. So now that I'm going to be looking at this specific point, I'm going to find the slope at this point, because that's going to be the same slope as what I want to use for my tangent line. So what I do is I take that first derivative and I'm going to plug in the point I'm interested in. I'm interested in 4, -7. The value of x is 4. So I'm going to take my first derivative. Every place there's an x, I'm going to put in 4. Now, just for fun, before I finish this, I also have a graph for this equation, and it looks sort of like this. Looks a little funky. Here's the origin. So it sort of comes down, curves, starts to curve again. So, and as it turns out, I'm going to be looking at 4, -7. So 4 is right here, -7 is here. So at this point right here, this is the point on the curve. Eventually, I'm going to draw the tangent line, and then we're going to find the equation of the tangent line at this point. So let's do the math, and then we'll come back and we will graph our tangent line, and we'll see if it looks correct. So let's go find the tangent line. So once again, first derivative, I'm looking at when x is 4. So I'm going to plug in 4 for x. 3/2 square root of x, square root of 4, minus 2 times x, 2 times 4, minus 32 over 4 cubed. So now let's do this calculation. Square root of 4 is 2. So if this whole thing is 2, hopefully you can see 2/2 cancels. I'm left with 3. 2 times 4 is 8, so 3 minus 8. And now I'm going to subtract. Now, actually, 4 cubed means 4 times 4 times 4, which is actually 64. 32 over 64 is 1/2. So what I really have here is 3 minus 8 is -5, minus 1/2, minus 5.5. Or I want to rewrite that as an improper fraction, -11/2. So this is the slope of the curve at this point, which is also going to be the slope of my tangent line. So now I have the slope. I know my point. I can now plug everything into the point slope equation and find the equation of the tangent line. So y minus y1 is -7, equals the slope. The slope is -11/2, x minus x1, x of my point is 4. So now I'm going to get rid of these parentheses and get y by itself, and then that should be the equation of my tangent line. So y minus the -7 is y plus 7. If I multiply out these parentheses, -11/2x. Now a negative times a negative is plus. Now if you can see, this is going to be 11 times 4/2. Well, the 4/2 reduces down to 2. So hopefully you can see that -11/2 times -4 is plus 22. So now if I get y by itself, I'll subtract 7 from both sides. So this now should be the equation of the tangent line at this point. So what I will do, I will go ahead and graph this on this curve and we'll see if it looks correct. So first of all, my y-intercept is like 15. 15, the y-intercept of 15 is like about here. And then it's going to go through this point. So once again, if I, wherever I set my ruler, to draw a straight line from this point to the point on my so once again, the idea is here's my curve or my function. We're choosing this point right here, and you can see this is the tangent line. And the equation of this tangent line is y equals negative 11 over 2 plus 15. And if I just want to check and make sure that this is actually the slope, negative 11 over 2, like negative 5.5. So I'm here at, if I'm here, this point here is like negative 15. If I move down 5, or sorry, let's move down 11 and over 2. So I'm right here at 15. So here would be 10, and here is 11. And then over 2, you can see the x-axis, distance of 2 is here. So I move over 2, yep. That's the slope of that line. So that's the idea of these problems. And you're going to be doing these problems over and over again, where they give you, once again, they give you a function or an equation. And they're basically saying, here's a point on the curve. Go find the equation of the tangent line at this point. We need two things. We need the point, which you've already got, and we need the slope. So how do I find the slope of my tangent line? It's going to be the same thing as the slope of the curve at that point. And the way I can find the slope of the curve is by taking the first derivative, plugging in that point, and going from there. All right, so I hope that's clear of what they're having you do.